right, now we're going to get to the nitty gritty of maintenance records. Now, doing maintenance records and logbook entries and all that kind of thing is something that you're going to do for the rest of your career. And it's something that as you progress up, you're going to become a lot more involved in. If you're kind of a courtesy mechanic out at an airport, just returning aircraft service that say like a small GA aircraft, you really need to know this because there is no there's no apparatus above you to kind of help sort through this and protect you. But like even in the heavy commercial world, as a guy on the line, they're usually going to have a system that's just set up for you to just kind of make your entries, and that we're going to show you how to do those types of entries. But when you become a team lead or you become a manager and you start to progress in responsibilities, making decisions is a big thing that you're going to do. You're going to decide whether or not this aircraft can be returned to service or not, if it's legal to fly or not. And those implications could have lethal effects if you do it incorrectly. And it will absolutely have legal effects if you do it incorrectly. So this is something that you want to really kind of understand and get to know. So let's get started with just some definitions. All right, these are all just Title 14 definitions. So Title 14 is the legal code that governs pretty much all of aviation. And at the very beginning of any kind of legal document, they're going to define terms. So that way everyone knows exactly what everybody is talking about. These are the definitions from them. And these are all going to be, there's a lot of definitions in there. They've been curtailed a lot to just be specifically geared towards maintenance. As we progress on and we get into some more technical, complicated subjects, we'll be revisiting different definitions, adding to our repertoire. All right, so first off, aircraft. It just means that a device that is used or intended to be used for flight in the air. That can mean a gyrocopter, it can mean a 777, it can mean a drone. That's all an aircraft really is. Okay, aircraft engine means an engine that is used or intended to be used for propelling the aircraft. It includes turbo superchargers. It's a weird way they push those together. Apparatus and accessories necessary for its functioning, but does not include propellers. So you'll notice, and that becomes kind of important because when we get to our power plants class, you'll start to notice that propellers are one thing and power plants are something else. You'll have an engine and a propeller, and you'll also have a propeller logbook and an engine logbook and an airframe logbook, and it all kind of starts right here with these definitions that they're separated. Okay, airframe means fuselage, booms, nacelles, cowlings, fairings, airfoil surface, including rotors, but not excluding propellers and rotating airfoils of engines, and landing gear of aircraft and their accessories and controls. So it basically means that the aircraft or the airframe is everything but the power plant and the propeller. That's pretty much it. Okay, approved. Now this is where we're going to start to get a little bit more maintenance centric. Approved is unless used with reference to another person, means approved by the FAA or any person to whom the FAA has delegated its authority in the matter concerned, or approved under the provisions of a bilateral agreement between the United States and a foreign country or jurisdiction. Now that last part you're going to see if you end up working for an airline and especially like a foreign airline. So EASA is the European version of the FAA, and you'll see a lot of similarities between the regulations, and it's because you have carriers that regularly fly between Europe and America. But by far, the FAA really is kind of the king ding-a-ling of regulation. Most regulations will follow whatever the FAA says, but they may not, and you want to pay attention to that in kind of the niche area. If you find yourself in like Cambodia returning aircraft to service, there might be a non-bilateral agreement. I don't know if Cambodia does have one or not, but that is something that with aviation is unique, that you're going to have to really pay attention to like where you're at and what are the rules that you're being held to, because you very well could be in Kyrgyzstan and putting aircraft back into service, or you could be, who knows, some say like Mauritania, which barely has anybody in it, and I doubt very seriously they have a really strong aviation regulatory body. I don't know, maybe they do. But the point being is that like there are little nuances to aviation that you need to be paying attention to, especially if you're going to be legally and ethically liable for the work that you're doing. Okay, so now let's just talk about maintenance. How does the FARs define maintenance? It says maintenance means inspection, okay, overhaul, repair, preservation, and replacement of parts, but excludes preventative maintenance. So maintenance, the easiest way to remember this is like maintenance, repair, overhaul. All right. So MROs, like big MROs, they take an airplane in and they do like serious heavy duty maintenance. They strip it all down, they put it all back together, they rebuild things, they repaint things, big time, like heavy checks to kind of like reset the aircraft and time it out and put it back into service. So that's like maintenance. Maintenance is big. Like we're gonna take the engine out, we're gonna rebuild it, and we're gonna put it back in. That's maintenance. All right. Preventative maintenance is different though. So preventative maintenance means simple or minor preservation operations and the replacement of small standard parts not involving complex assembly operations. So almost everywhere you go, you're going to have a bifurcation of maintenance activities. You're going to have like heavy maintenance and you're going to have line maintenance. All right. Now, like in the Army, you have line units, and those are the ones that actually own the aircraft, and they put them up in the air and they land them, and you'll have guys that go out and do like daily checks, and they're just like kind of inspecting. You do preventative maintenance, like 20 hours, 40 hours, that kind of thing. But then once they hit like say 100 hours, and it's time to do like real heavy maintenance, they're going to tear everything apart. They're going to do a lot of servicing. They're going to remove and replace and different filters and all that good stuff. Then that falls into a heavy check scenario. So like I said, like in the Army, you have like line companies, then you have AVM, Aviation Intermediate Maintenance. They move it over to like the guys that do phases. In the airlines, you're going to have a very similar dynamic. You'll even have there's even like MROs that specialize in line maintenance, and they're contracted guys that just do preventive maintenance. They turn things at the gate and send it back, and that's all they really do. And then you have other MROs that specialize in the majority of them actually do like real heavy maintenance, like we were saying earlier. And you'll see that in just about every organization that's out there. If you go work for an airline, like you'll have guys that work the gate and they're line maintenance, and then you'll have guys that work heavy maintenance, and they do they're in the wheel shop, and so they change brakes out all the time, or whatever the situation may be. Now there's a slight wrinkle to it. So if you're in like a specialty shop, say like avionics, like you might be floating between the two on a regular basis. It just depends. It depends on how big the operation is and how they're running things. But if they can only afford a handful of avionics guys, you might be going over there doing aviation or avionics pre-flight on an aircraft that's being returned to service at the gate, and making sure that everything's kind of up to snuff. Doing functional checks and that kind of thing. You might go over to the heavy check stuff and replace a whole wire run, and then do a big inspection or functional test on that. It really kind of just depends on where you're at, and so there is a little bit of wrinkle there. But just know that there's two camps. There's like heavy maintenance and there's line maintenance, and that means a lot for your careers. Like, where do you want to go? Do you want to be a line guy or do you want to be a heavy guy? And the kind of the way things tend to happen is they put you in a heavy maintenance environment first, so that way you can learn, because everything's a lot slower. There's a lot more people there for you to learn from. There's a lot less autonomy. You're not expected to know everything. You're expected to ask a lot of questions. And then you progress into line, and then you sit at a gate, and aircraft shows up, and you do whatever it is you need to do, or run around and fix whatever it is you need to fix. Then you're the one that's signing off the logbook, giving it back to the pilot, and sending the aircraft out. That's you generally kind of seen as the more mature, aircraft mechanic is at the gate, being the line guy. But there's plenty of guys that have been doing it for 40 or 50 years, and then they stay in heavy maintenance because that's what they like. and so it's it's slower, generally a little bit less drama, and you can really take the airplane down to brass tacks. I mean, just really strip it down and then really build it back up again. There's a certain reward to that as well, but there's also a lot of reward to just the drama that happens whenever you're trying to get a flight out too. So just know that those are those two camps. Okay, time and service. All right. So time and service with respect to maintenance time records means the time from the moment an aircraft leaves the surface of the Earth until it touches it at the next point of landing. So time and service is an interesting one because it all kind of comes down to the time the aircraft is actually in the air, not necessarily running. Depending on the maintenance criteria, time and service could potentially be the criteria in which you are tracking maintenance. It could also be just Hobbs hours. Basically, if the airplane turns on, the clock is running. It could be TAC hours, like if the engine turns on, the clock is running. It just depends on what you're doing. And the maintenance manual will tell you this. It'll tell you, say like, hey, look, on so many cycles is another one, and depending on how many times the aircraft is pressurized and depressurized, because that stresses the airframe, so it can only have so many cycles before maintenance needs to happen. It could also be how many starts as another kind of maintenance tracking device, where it's like, okay, well, like this engine has so many starts, and after so many starts we need to do X, Y, or Z. It could just simply be time. One of the things with private jet maintenance that a lot of people don't realize when they buy them, they're like, oh, well, as long as I fly under so many hours, I should be okay on maintenance. I shouldn't have to pay for that. That's true to an extent, but there's also just simple, like, hey, look, just like you have to, your truck has an oil change every 3 months or so many miles. A private jet will have like, hey, look, you have to do these checks every so often, because it doesn't really matter how much you use it. Corrosion still is going to happen, or whatever. There's like a time limit on these parts, and so you're going to have to really kind of pay attention to that. But the point being, it's like time and service. It's a good definition for that one criteria. But just know there's a lot of criteria out there, and the maintenance manual will tell you what the criteria is to track for different parts and pieces of the airplane, and something that you want to get. Like if you're a guy that is going to take an aircraft in and analyze the logbooks and say, like, what do we actually have to do to make this aircraft legal and safe to fly? These are things that you need to know, because it's not just the time the aircraft has been alive, like what's it due for, but it's also the flight hours that it's run up. It's also the checks, or the starts. It's also the cycles. And there's all these little things that you need to know and get familiar with in order to know what an aircraft actually needs, what maintenance it actually needs. Okay, major alteration means, what is a major alteration? Means an alteration not listed in the aircraft engine, or propeller specification that might appreciably affect the weight, balance, structural strength, performance, power plant operation, flight characteristics, or other qualities affecting airworthiness, or that is not done according to the accepted practices or cannot be done by elementary operations. So basically, all that's saying is that, like, if I'm sitting out on the flight line and I'm running up my airplane and a deer runs out and smacks the side of it and puts 8 points of holes all the way through the side, there's not a maintenance task. I go to the maintenance logbook or the AMM and start looking there. It says like, okay, like where is the if a deer runs into the side of your airplane kind of repair. No, you're going to end up, that's like a whole boondoggle that you're about to go on. And that would be a major alteration, because let's say if we just say like, okay, we're just going to slap some sheet metal on there. Well, even if that was an authorized repair, we still have just added weight to the airplane at a certain distance from the datum, and so that throws the CG off. And so that would constitute a major alteration because we've added something to the airplane. Okay, so major repair. Major repair means that if improperly done, might appreciably affect weight, balance, structural strength, performance, power plant operation, flight characteristics, or other quality affecting airworthiness, or that is not done according to accepted practices or cannot be done by elementary operations. So a major repair would be like pulling an engine. So if we pull an engine, then that's a major repair. It's not an alteration because we're going to follow the task that's laid out in the AMM. That we're going to say, this is what we do to pull the engine, this is what we do to install the engine, and we can say on there like, I certify I did it per these tasks in the AMM. But it's still a major repair, and that's going to constitute a certain level of documentation that we'll get into here in a little bit. Okay, so a minor alteration and a minor repair. Pretty easy. A minor alteration is anything that's not a major alteration. A minor repair is anything that's not a major repair. It's real simple. Okay, so we want this course to be focused on heavy commercial aviation. Heavy commercial aviation has its own kind of atmosphere, its own kind of culture, and it also has a lot of its own definitions. So one that you'll hear a lot, and one that next time you're flying, if you're around a lot of airplanes, look at the nose gear, and you'll see this definition stamped onto the nose gear door. And it's called ETOPS, Extended Operations. Means an airplane flight operation other than an all-cargo operation in an airplane with more than 2 engines, during which the portion of the flight is conducted beyond the time threshold identified in Part 121 or Part 135 of this chapter, that is determined using an approved 1-engine inoperative cruise speed under standard atmospheric conditions in still air. So that's a big mouthful, but essentially all ETOPS is saying that, like, okay, we have an airplane that has 2 engines, all right? Now, if one engine were to go out, how far can it fly on the singular engine in the best case scenario? So that's why I say it's still air. There's no kind of crazy wind blowing, or they're not fighting into, like, how far can it go just with one engine? And so the kind of history behind this is that whenever they started flying aircraft, they'd be flying along, and then they would lose an engine, and then they would be far away from an airport where they couldn't land just on one engine. And so then they were like, we got to do something about this. So then they started saying, like, okay, well, all right, if you're going to fly a twin-engine aircraft with people on board, then you have to stay within a kind of a range of your singular engine performance. And it was like, they would call that ETOP. That was the original ETOPS. It was like ETOP 60. Usually it was within an hour flight with one engine of an airport. So that created a pretty interesting dynamic, because that meant that, like, there was only like certain routes that you could take. So then the game became like, okay, like, how far can we fly on just one engine alone, so that way we can extend our range and we can make more efficient routes. And so, like, you get to like ETOPS 120. So also now it's not just, within an hour, it's within 120 minutes. And so, like, all of a sudden you could do all kinds of like new and creative flights. And as time progressed on and as technology progressed on, they made engines more and more efficient. You get to, I think we're on ETOPS 360 now, which means that basically you can fly just about anywhere in the world direct, because like the plane can fly, indefinitely for, well, not necessarily indefinitely, but for 360 minutes straight with just one engine and be okay. That opens up the world to a lot of very cool and interesting places, whereas before maybe they couldn't get there. Like, it would be very, very hard to land in, say, the Maldives under ETOPS 60, because I don't think there was ever a plane that could actually land there within a 1 hour flight on one engine. So that's ETOPS, and that becomes like a big thing, especially if you're working for like a major air carrier that operates over the water, or you're working at an MRO that services those planes. Is that, like, you'll hear people say, like, does this affect ETOPS? Is this like does this have to, is it an ETOPS system? Does it downgrade it? So that's it. And then, like, so Part 121 and Part 135. 135 is an air charter operation. So, like, if you go down to, like, that down in Longview, there's a 135 operation that you can charter a private jet. So that's a 135. 121 is like an airline. And so what's saying, what is saying is that there's ETOPS rules in those. So if you find yourself working to either one of those, you'll want to get familiar with those parts of the FARs, so that way you can understand the legal implications of what you're being asked to do. Okay, so ETOPS significant systems means an airplane system, including propulsion system, the failure or malfunctioning of which could adversely affect the safety of an ETOPS flight, or the continued safe flight and landing of an airplane during ETOPS diversion, which means that like they're on one engine. Each ETOPS significant system is either ETOPS Group 1 significant system or ETOPS Group 2 significant systems. So let's talk about these two groups, and we'll kind of talk about it again. ETOPS Group 1 significant system has a fail-safe characteristics directly linked to the degree of redundancy provided by the number of engines on an airplane. Is a system the failure of or malfunction of which could result in an IFSD, loss of thrust control, or loss or power loss, contributes significantly to the safety of an ETOPS diversion by providing additional redundancy for any system power source loss as a result of an inoperative engine, is essential for prolonged operation of an engine at engine inoperative altitudes. All right, so ETOPS Group 2 significant system is an ETOPS significant system that is not an ETOPS Group 1 significant system. Okay, so Group 1 examples would be something like hydraulics, fuel supply system, things that just simply make the engine run. That like if all of a sudden like you lost all of your electrical power and you have like a FADEC controlled system, and so that means like generators, batteries, everything's gone. Well, you basically got a glider on your hands. You're going to deploy the rat, and you're going to try to like get the power coming back on. But like you're in a in-flight diversion scenario. You need to get on the ground quick. That's a Group 1 system. Group 2 system are like they are still significant systems, but they aren't going to take you completely out of the air. So for instance, like your navigation systems, all of a sudden you just couldn't navigate anymore, and you're like looking out the window trying to fly along. That's a significant ETOPS system, but it's not a Group 1 system. It doesn't mean that like just because you can't navigate, it doesn't mean the airplane's about to fall out of the sky. You just don't know where to go. So that would be like an example of a Group 2 ETOPS system. All right, so let's talk about, now that we know what ETOPS is, the configuration maintenance procedures document. It means a document approved by the FAA that contains minimum configuration, operating and maintenance requirements, hardware life limits, and most importantly, the Master Minimum Equipment List, or MMEL, or the frequently referred to as the MEL. Constraints necessary for an airplane combination to meet ETOPS type design approval requirements. Okay, so every airplane has all kinds of systems on board. Some of them are significant for flight, and they have to be operational for them to work. And sometimes they don't. So for instance, if you get on the airplane as a passenger and you sit down and you're like all amped to watch the latest movie that came out, and the screen in front of you doesn't work, well, that's not a significant flight system. It's not going to cause you to not be able to fly the airplane and get to where you're going safely because the in-flight entertainment system went down, which it does all the time. So that can be deferred at the gate. So if, let's say, the pilot tells the mechanic, "Hey, look, our IFE system's down, and we need to write it up." The mechanic say, like, "No problem. It's not an MEL item. We're just going to like write it up, and we're going to just like defer it until it gets to a point where the aircraft is down and somebody can come on there and start troubleshooting it." But if the pilot comes to the mechanic and says like, "Hey, I can't get the number one engine to crank," well, the number one engine's is pretty significant. It's not. It is on the minimum equipment list, and so you can see what that aircraft, if it has an approved, not all aircraft have. Like our Lear doesn't have an approved MEL. Like I say, like a Southwest Boeing 737 will have an MEL. So you'll be able to find that in Chapter 25, and it'll tell you. It'll say like, "Hey, look, this is what's the MEL for this airplane," and you'll want to know that if you're sitting at a gate somewhere and the pilot comes up to you and says like, "Hey, like X, Y, or Z doesn't work," well, your first deal is like, is that an MEL item? Over time, you kind of get to know. You'll get a sense of like what is significant and what's not. If they, like, for instance, like if the the lav lights out. I don't think that's a significant system. It could be, depending on the agreement that airliner has. But you would want to go to chapter 25, look at it, and say like, okay, well, that's not on the MEL, so we can just defer it for maintenance. But if it is on the MEL, that means that we stop and we actually start to work on that problem right then and there, because that takes that aircraft out of service. Okay, another little nuance with MELs. So the master minimum equipment list, the MMEL, is for like all of an aircraft. The FAA says that, like, all aircraft have to have wings, okay? But what is known as just an MEL, not an MMEL, and what is often referred to as MELing things, is for a specific carrier for a specific aircraft. So, for instance, let's say you are flying on an Envoy plane. Okay, they are still under the master minimum equipment list for a 737. All right, and I don't know that they don't have a 737 MAX, but let's say they only had 737 NGs. Okay, and so that MEL applies to both Envoy's 737 NG and for Alaska's 737 MAX. But Alaska will have a different MEL for specifically flying the MAX. You'll have like the MMEL, with big umbrella for 737s, and then underneath you have, for Alaska's agreement with the FAA for their 737 MAX, just an MEL. So that is a little nuance that you'll want to know going forward. All right, so other things in the CMP, it'll have all of the like life limited parts and all the little details that you'll need to know whenever you're analyzing an aircraft for what maintenance needs to be done. So that's a document that you'll want to have in the back of your mind to refer to as you start to process that information. Okay, so let's say you're back in that situation, that you're at a gate, and the pilot comes up to you and says, hey, X, Y, or Z thing on the airplane doesn't work. What does the FARs tell you that you can and cannot do? Okay, so we're going to read Part 91.213, all right? Inoperative instruments and equipment. What do you do? Okay, so just right off the gate, it says, except for as provided in paragraph D, which we'll get to, no person may take off an aircraft with inoperative instruments or equipment installed unless the following conditions are met. So it means that, like, if something is broke, airplane doesn't fly unless there are a few things. Number one, an approved minimum equipment list exists for that aircraft. All right. So this basically says that, like, we've sat down with the FAA as, like, say, me, the airline, and we've come up with, like, what is going to be on our MEL, what is the bare minimum that we need to fly an aircraft safely, and we see eye to eye on it, and then we put that in our AMM and our CMP and say, like, hey, look, these are the bare minimum things that we need to go fly. If that exists, then we can turn around and say, like, oh, the thing that was broke was the IFE system, and we don't need to really watch movies while we fly to be safe, and so therefore we can just defer it because it's not an MEL item. All right, situation number two. The aircraft has within its letter of authorization issued by a responsible flight standards office authorizing operation of the aircraft under MEL or under a minimum equipment list. The letter of authorization may be obtained by written request of the airworthiness certificate holder, the MEL minimum equipment list, and the letter of authorization constitute a supplemental type certificate for the aircraft. Essentially, if you have a situation, then you call a FSDO, which is the Flight Standard District Office, and say, like, hey, like, here's the situation that we have. And they'll say, like, oh, we get it, like, that's still safe to fly, here's a letter. And that constitutes an STC. If you remember from our STC class, like, we have our TCDS, this is like type certificate data sheet that says, like, this is the configuration the aircraft has to be in to fly. And then a diversion from that is a supplemental type certificate. It means that, like, hey, look, we put something on the airplane, or we took something off the airplane, or we changed something about it from the original TCDS to a new configuration, and the STC says, hey, that's it. It's the same process. Basically, you're calling the FSDO up and saying like, hey, look, can we just like, not fix this thing or take this thing off or placard it or whatever the situation is. They say, yeah, sure, here's a letter, and that constitutes an STC. Okay, the third situation. The approved minimum equipment list must be prepared in accordance with the limitations specified in paragraph B, which we'll get to. Provided the operation of the aircraft with the instruments and equipment in an inoperable, provide for the operation of the aircraft with the instruments and equipment in an operable condition. Basically, it says that like the MEL says like, hey, look, if this system goes out, is there another system that can supplement? And so let's think, and I don't know that this is the case, but like, let's just kind of use it as a hypothetical. If you look on a 737, you're going to have like GPS WAS, then you're going to have an ADF, and you're going to have a VOR. You're going to have all these different navigation systems. And then they'll say like, hey, look, the GPS, went out. Well, they're like, okay, we can defer that because we have the VOR system. We have, on the 737, there's usually 2 VORs that you can draw from, or if not more. And then let's say like those also went out. Like, okay, well, we can defer that because we have an ADF, which you don't really want to navigate with an ADF. But if you had to, you could. And so you would have those abilities to continue to like have those redundancies as you go on. But let's say the ADF goes out, they're like, okay, well now like we're into a systems 2 ETOP scenario, and like we can't fly this plane because we can't navigate with it, and so it has to get fixed first. That would be what they're talking about here. Okay, number 4, the aircraft records available to the pilot must include an entry describing inoperable instruments and equipment. We're going to talk about that here in just a second. The aircraft is operated under all applicable conditions and limitations contained in the MEL. So, like, one of the scenarios with this is that, like, you'll see this a lot with your different auto lands. If all of a sudden like the auto land system can't work, it doesn't take the aircraft out of service, it just downgrades it from auto land. And so basically your maintenance entry would say like, hey, look, this has been downgraded, you can't use auto land, certain things have to happen in the cockpit and in the logbook, and you tell the pilot, hey, look, auto land's out. You can still fly the airplane, you can take it, you just have to land it, the old fashioned way. And that's a pretty common, thing that actually happens. Okay. So we've determined that like the thing that the pilot has complained about isn't on the MEL, and we're gonna defer it. We're gonna fly to the next place, and we're gonna fix it there. Common situation. But what has to happen? There's certain things that have to happen to the whatever the system is in order to make it legal. So Part 91 says inoperative instruments and equipment are 1. Removed from the aircraft cockpit control placarded and the maintenance record in accordance of 43.9. All right. And then 2, deactivated and placarded inoperative. So essentially, let's go back to our IFE. Let's say that the IFE's area box is out. What we're going to do is we're going to write it down in the logbook. Hey, look, and like IFE is manifesting these issues, and we deferred it. We're going to go into the cockpit. We're going to pull a circuit breaker for it. We're going to tag it out, and we're going to say like we're going to take a sticker that says inoperative and put it on there, and then on the switch, if we can secure the switch, we will, and then we'll actually put inop on there as well. And you'll see this pretty commonly in most airplanes. Like you'll sit down and you'll look at things. It'll say like, hey, look, here's a, like my airplane, the clock doesn't work. Now it's not IFR certified, so I'm not really worried about it. And I'm not, itching to go replace the clock. But but to be legal, it has to be annotated in the aircraft logbook, and it has to have inop on the clock. So that way there can be no confusion over whether or not the clock works or not. So let's say if I were to rent out the airplane to some other guy, and he's flying along, and he looks at there and he says like, oh man, like it's 3 o'clock in the afternoon. It's really like 11 a.m. I've been flying for a long time. I'm gonna have to like make an emergency landing because the fuel gauge must be broken since the clock says 3 o'clock, and I've been in the air for all these hours. Now, it would take a special kind of person to make that kind of mistake, but you can see where the FAA is coming from in making sure that like there can be no bad information being like injected into the pilot's mind And so therefore we use the Inop sticker for that. Okay, so what does that maintenance record that we have to make look like? So Part 43.11, the content, form, and disposition of records for inspections conducted under Parts 91 and 125 and 135 and 135.419. It says maintenance record entries. The person approving or disapproving for a return to service of an aircraft, airframe, aircraft engine, propeller, appliance, or component part for after any inspection performed in accordance with 91, 125, 135, 135.49 shall make an entry in the maintenance record of that equipment containing the following information. So it's got a couple things that your maintenance records has to have. Number one, the type of inspection and a brief description of the extent of the inspection. A lot of times you can just say like, this is a general visual inspection, a GVI, or the best way to do it is like, I inspected, component A in accordance with, ATA chapter task, like 25-01-01, whatever. The number two, the date inspection of the aircraft total time in service, the date of inspection and the aircraft total time in service. So essentially, you're going to say like, I did this inspection per this on this date, and then in brackets you'll say like aircraft time, blah 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 blah, and that allows you to people to start to build a picture of like, when did this happen? It's like, okay, it happened on this date, and then the aircraft had this many hours. Okay, and then number three, the signature and certificate number and the kind of certificate held by the person approving or disapproving for return to service the aircraft, airframe, aircraft engine, propeller, appliance, component part, and portions thereof. So essentially, you're going to put like like Brandon Sanders, A&P, and then your number, which mine's like got a lot of fours in it. So 4044644, and then those brackets. And that's how you'll sign that off. Number four, except for progressive inspections, if the aircraft is found to be airworthy and approved for return to service, the following or similarly worded statement: I certify that this aircraft has been inspected in accordance with insert type inspection and was determined to be in airworthy conditions. So like you would say like, I certify that this aircraft has been inspected in accordance with AMM task, blah, 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 blah. Inspection and was determined to be in airworthy conditions. Okay, number five, except for progressive inspections, if the aircraft is not approved for return to service because of needed maintenance, non-compliance with applicable specifications, airworthiness directives, or other approved data, the following or similarly worded statement: I certify that this aircraft has been inspected in accordance with AMM task inspection and a list of discrepancies and unairworthy items dated the date has been provided for the aircraft owner or operator. So like you'll say like, hey, look, we did an annual. These things are broken, and so like it failed its inspection, and you'll say in the logbook that I gave the aircraft owner the list of things that were wrong. For progressive inspections, following the similar worded statements. So that this is for progressive inspections. I certify that in accordance with the progressive inspection program, a routine inspection of identify whether the aircraft or components of the propeller or whatever, and a detailed inspection of identify the components were performed of and the aircraft components are approved or disapproved for return to service. If disapproved, the entry will further state a list of discrepancies and airworthy items dated has been provided to the aircraft owner or operator. All right. So like the so what is that on your maintenance logbook entries, Part 43 basically lays it out for you exactly what to say. You don't have to worry about it. You just have to simply like fill in the blanks. One of the best ways to do this, if you're in an operation where you're actually making logbook entries on a pretty regular basis, you get to like some like bigger carriers and stuff like that, it's going to be a lot different. But if you're working at a small MRO that's turning private aircraft on a regular basis, the best thing to do is to save this on a Word file, and then just simply like update it as necessary, print it out, cut the piece of paper out, and then glue it into the logbook and then sign it. That way, like, it's very easy to read, it's right there, and it saves you a ton of time rather than hand jamming that thing out all the time. Okay, so placarding. Placarding's another big thing that you're going to do on a regular basis, and it's pretty easy. You should have a label maker with you, so that way you can, like, label make, not just like, in op times, but like, let's say you do an oil change, it'll say, like, next oil change is due at such and such tack time. But anyways, the placarding is also laid out. It says, for those items permitted to be inoperative under 91, that person shall place a placard that meets the aircraft's airworthiness certification regulations on each inoperative instrument and cockpit control of each item of inoperative equipment, making it inoperative, and shall add the items to the signed and dated list of discrepancy given to the owner or a leasee. So essentially, it means that, like, it says it should say inoperative. Most of the time, people just put inop, and everyone knows what that means, and that's the way it goes. Okay.